George Simon Ohm and Ohm's law. George Simon Ohm is a scientist of the 1700s that studied with electrical currents as electricity was just getting big. His contribution to electricity led to the concept of resistance, current, and also voltage and the relationship between those things. As we look over this sheet, we're going to discuss Ohm's law and see how it works and how we use it. George Simon Ohm first considered three things inside of electrical circuits: the voltage, the current, and the resistance. Let's go first look at voltage. The voltage of a circuit is supplied by the battery. And it's defined as the motor or the push that causes current or the movement of electrons. So we'll say that voltage is the force that produces current or electron flow or electric flow. Okay? Voltage is taken in units of volts. And the symbol for the volt is V. Next, we have current. Current is the flow of electric charge. Electric current is measured in units of amperes. And the short term for it will be amps. More commonly, you probably heard of the term amps more than you've heard of amperes. You say, amps for a car, things of that sort. Resistance slows down electrical current. Resistance is taken in units of ohms after George Simon Ohm. And the symbol for the ohm is actually a Greek letter, the omega sign. Some of us are used to alpha, omega, beta, but this is the omega symbol. Let's go look at the relationship that Ohm figured out. Which is the original equation in the first problem, or problem 4, states the equation that voltage equals current multiplied by resistance. So therefore, V equals I times R. That I is a symbol for current, and the symbol for resistance is R. As a result, we also need to be able to solve for current and resistance if we had to. So here are the other equations which we'll deal with question 5 and question 6. So question 5, to solve it for current, we have to solve for I. Let's divide each side by R. So we have V equals IR, divide each side by R. That cancels the R's. So I get I equals V over R, and that's the answer for number 5. And number 6, V equals IR is the original equation. I need to solve it for now R, dividing side by I. Cancel these guys out. That means that R equals V over I. All right, we have a couple of practice problems, but before I get to the practice problems, I want to kind of discuss a couple of things. The first concept is, what are we using this for? And we're using this for circuits, and the circuits that we're going to be concerned about today will be series circuits. We drew some of these inside class the other day. So if I have a series circuit, and let's say I have a couple of light bulbs. So I have one here, and I have another one there. And I want to connect these guys. There's a couple of things I can figure out. Well, first thing, what if I had a battery that was 9 volts? Okay, like your traditional 9-volt battery you get from the store. And I was told that each light bulb had a particular resistance, because remember, light bulbs are a type of resistance. And let's say this one had a resistance of 3 ohms, and this one had a resistance of 3 ohms. And someone asked me, what's the current of this circuit? So what is the I of this circuit? What does it equal? Well, I know the equation for I. The equation for I is that current equals voltage divided by resistance. That makes a lot of sense looking at that. It means that as the resistance increases, the more stuff you have on the circuit, that means the current should decrease, or therefore, you know, like if you have light bulbs, the more lights you add, the dimmer they're going to be. Okay? So let's go solve this question for those two things. Okay? In this case, my voltage, so I have I equals, my voltage is 9 volts, but I have 2 resistances. I have 3 and I have 3. So what do you think I probably should do with those? Yeah, the answer should be to add them up together. So my total resistance is 9 ohms. This adding up of resistances only works for a series circuit, which is what type of circuit this is. If it's a parallel circuit, you do it another way, but you don't have to worry about that for this sheet. In this case, the 9 cancel out, and this 9 cancel out, and I'm left with 1. Since I'm solving for current, I know the unit for current will be amps or amperes, so I want to put amps for this. So the answer for this is 1 amp. Let's go look at the example problem, question number 7. Number 7 reads, a series circuit has a current of 26 amps. And a total resistance of 5 ohms. Then it asks, what is the voltage of the current? So I'm solving for V. Okay? As a result, I know the equation for V, which is my original equation that states that V equals IR. The next step is to substitute on my guess method. So instead of writing I want to write down 26 amps. Instead of writing down R, I'm going to write down 5 ohms. And as a result, I just multiply 26 times 5. And the answer is 30. Since I'm solving for voltage, I know it should be 130 volts, because that's the units for voltage, just kind of going back to that last sheet. This right here is the answer for question number 7. Let's go look at question number 8. Question number 8 states a series circuit is wired with a 12-volt battery. That 12 volts has to be the voltage. And consists of a light bulb that has a resistance of 4 ohms. So it has one light bulb that has a resistance of 4 ohms. And then it says determine the current of this circuit, which is I at any given point. So I don't know what I is. I have to figure out the equation for I. It says V equals IR. Okay, I can look and search for I as well. And the equation for I is that I equals V over R. Okay? This is similar to the first example I gave you when I just drew the picture of the circuit. So in this case, I'm going to substitute next where I equals V over R. So I equals 12 volts over a resistance of 4 ohms. And then after that, 12 divided by 4 is 3. And I'm looking for current, and I know that that's taken in ounce. So the answer should be I equals 3 ounce. Let's go look at number 9. Number 9 states, Justin connects a new radio system to his car in a series circuit. If the battery supplies a voltage of 12 volts, to the radio, and there is a current of 6 amps, determine the amount of resistance that the radio system has. The equation to solve for R is R equals V over I. The next step is to substitute. So instead of writing V, I'm going to write down what V equals, which is 12 volts, and I is 6 amps. 12 divided by 6 is 2. I'm looking for resistance, so therefore the unit should be ohms. So that's the answer for number 9. The rest of the questions, questions 10 through 14, you'll do on your own. As you read through these questions, and if you need help, review the questions that you have previously, questions 7 through 9, and also look over your equations. There's a couple of equations in which you have more than one resistance. All these circuits are series circuits, so that simply means add up the resistances in order to figure out the total resistance. Good luck. If you have any questions, please ask your instructor.